So, I am Dr. Lutsmiri, Associate Professor in the Department of Computer Science and Engineering. I am going to take the file system interface and file concepts and access method in the Linux file system from the subject operating system. The subject code is FX CS8493. Core subject is we have to have the file system interface as well as the file concept and access methods. So, to the user, Linux file system appears as a hierarchy directory being Unix semantics. So, generally, internally the kernel hides implementation details and manages multiple different file systems via an abstraction layer. That is the virtual file system. The virtual file system is designed around the object-oriented principle and is composed of four components: the inode object, the file object represents an open file, the super block object, and the de-entry object. The inode object structure represents an individual file, and a file object represents an open file. The super block object represents the entire file system. A de-entry object represents an individual directory. File system appears as internally it divides. It has an operation user include like Linux fx. ext3 is a file system. It's a standard for Linux file system for Linux. So, it uses a mechanism similar to that of fast file system, supersedes older ext.fx, ext3 file systems. So, many file system choices of the Linux distros. So, main difference between the previous system is in a fast file system, the disk is allocated to files in blocks of 8 KB, with blocks being subdivided into fragments of 1 KB. So, ext3 do not use fragment, it performs allocation in smaller units. It uses the cluster allocation policies designed to place logically adjacent blocks of a file into physically adjacent blocks on a disk, so that it can submit an I/O request for several disk blocks as a single operation on a block group. It maintains a bitmap of free blocks in a block group, searches for free byte to allocate these 8 blocks at a time. So, it's a previous journaling. ext implements journaling with file system updates first written into a log file in the form of transaction. So, once a log file considered committed over time, a log file transaction replayed over file system to put changes in place. On system crash, sub transaction might be in journal but not yet completed into file system. So, must be completed once the system recovers. No other consistency checking is needed after a crash. It improves write performance on hard disk by turning the random I/O into sequential I/O. So, procedure file system does not store data, rather the contents are computed on demand according to user file request. It implements directory structure. It uses a inode number to identify just what operation is required when a user tries to read from a particular file inode or perform a lookup in a particular directory inode. When data is read from one of these files, procedure PROC collects the appropriate information, formats it into text form, and places it into the requesting process. Passing between the pipe mechanism allows a child process to inherit a communication channel to its parents. So, the data written to one end of the pipe can read at another. The shared memory offers an extremely fast way of communicating, and data written by one process to a shared memory region can be read immediately by any other process that has mapped that region into the address space. So, how to obtain the synchronization between the processor? The shared memory must be in conjunction with another